Hello, this is Andy Schweitzer, and I'm doing a quick little video here on a review for our test. It says to write the equations out, translate, balance if needed. Usually it says indicate the type of reaction as well. So we have aluminum acetate, C2H3O2 plus sodium metal. Now this is a redox reaction. So we have sodium metal will take the place of the aluminum, and the aluminum will be all by itself, and it will be sodium acetate, C2H3O2 plus 1 minus 1. So that's good to go here. Do need to check the reductions potentials. I have aluminum going to the aluminum metal and sodium going to sodium. And in this case, we can check our reductions potential. And at this point, first what I'm going to do is the aluminum. The aluminum is going from a +3 to aluminum metal. It's a -1.66 volts. Alright, so flip back here again, aluminum ion to aluminum metal. And that is what's happening. It's going from aluminum ion to aluminum metal. So this is going to have to gain 3 electrons to get that point. And it is a -1.66 volts. The other one is going to have to get flipped. So at this point, flip reduction potential for sodium cation. It should be a little higher here. Let's find it here. Alright, so maybe not. Alright, sodium, oh, there it is. And it is reversed. It starts out at the metal and goes to the ion, so I have to take this thing and flip it. Positive 2.71. And in this case, plus 2.71, and at this point, get out of there. Add those two things together. In this case, subtract them, and we will still yet yield a positive voltage. Looks like we're about 1.1 something. Subtract that 1.4 maybe. Either way, you do have a positive voltage. Make sure you subtract it. If you get a positive voltage, it means the reaction will run. You should balance it, and then there we go. So either way, that one is good to go. Balance-wise, 3 acetates give me 3 acetates, 3 sodiums gives me 3 sodiums. I have hydrogen gas plus oxygen gas, right? H2 plus O2 yields H2O. Simply balance. Cobalt sulfide is right here. Cobalt sulfide. You need to look the charge up on cobalt. It's a +2, -2, plus nickel. And if for some reason there's more than one charge, you can just pick one. -1. And then cobalt chloride +2, -1, plus nickel sulfide +2, -2. Alright, this is a solubility reaction. This is a synthesis reaction. We need to check solubilities for each of these. And in this case, solubility for sulfides. Let's do that one first. Sulfides are generally insoluble. I don't have a cobalt here, so this will be a solid. And the chloride is generally soluble, and I don't have the exception here. So, at this point, this will be an aqueous. Still a good reaction with a solid forming, and it looks like it's already balanced. One of the biggest mistakes people make is forgetting to charge balance these. So even though I just left it till the end, make sure you get on that right away, especially when balancing. There should be a 2 here as well. Do not forget charge balancing. That is a major way to lose points. Either way, number 4, ammonium silicate. So I have NH4 SiO3 parentheses 2 -2 plus 1 plus potassium phosphate PO4 -3 plus 1 yields ammonium phosphate. And again, these are just potential products. We need to check solubilities. Potassium silicate SiO3 minus 2 plus 1. And since they both have quick check solubility compounds, ammonium and the potassium, both are AQ. And this is a no reaction, no new solid formed. Barium chloride plus lead nitrate, BaCl2. This is a plus 2 minus 1 plus Pb. Again, there should be a charge here. There is not. I'm going to just go lead 2 nitrate. Alright, NO3, 2 plus 2 minus 1. You could choose 4 if you'd like. So we have lead chloride. Alright, plus barium nitrate. And parentheses 2 plus 2 minus 1. And this will be an AQ because of the quick check. The chloride, looking for lead chloride. Here's chlorides. Chlorides are generally soluble, except for, of course, lead chloride. And in this case, we will put a solid here. This is a good reaction. Balance it. 2 chlorides, 2 nitrates. Looks like everything is balanced. Alright. This is a no reaction. And this one here is a solubility. Alright, sodium metal plus chlorine gas yields sodium chloride plus 1 minus 1. That's how I know that the formula. 2 chlorines, 2 chlorines, 2 sodiums, and is a synthesis reaction. This guy right here, number 7, is a full reaction. Just simply translate and balance. I'm not gonna, I'll just translate here. PbNO3 goes to PbO, and plus we got nitrogen dioxide and oxygen gas, and you can balance it on your own. Yeah, this is decomp. You should note that in our test you'll decompose to elements. So if you have this, you just decompose it to lead, nitrogen, oxygen. Alright, number 8, magnesium metal plus sulfuric acid, H2SO4. And this will be a redox. Alright, and we'll have magnesium going to, give myself some room here, but it'll be magnesium sulfate plus 2 minus 2, and then H plus going to H2, no charge. So my half reactions for this guy are as follows. I have magnesium, no charge, going to magnesium 2 plus 2 electrons, oxidation. And then I have my H plus going to H2, no charge, plus 2 electrons, because I have 2 of them. Let's get the voltages for these guys. And this is the reduction, so that we ran that chart. Reduction, right, it should be, alright, looks like this guy here this is a relative scale, so the hydrogen actually is 0. We can go ahead and put a voltage equaling 0 for that guy. And now I gotta take my magnesium, it's oxidation, so I'll have to flip it, and Mg2 plus, and let's find here, Mg2 plus, flipping it would be a positive 2.37 volts. So this is also good, plus 2.37 volts. Add those together and you get a voltage of 2.37. And it is a good reaction. Balance it. It looks like it very well could be balanced already, and it is. Number 9 is a combustion reaction. I give you everything here, but you will not get that on the test. So it's going to be C2H6 plus O2 yields CO2 plus water. Balance it. We have 2 carbons, 6 hydrogens, 3 oxygens plus 2 plus 4 more is 7. Cannot get 7 here, so we double everything. 2 and 2 is 4. This becomes a 4. This becomes a 6, and then add up your oxygen. 6 plus another 4. Well, 8 would be 14, so a 7 goes right here. And the last one is chromium chloride plus 3 minus 1. Again, check your chart for charges. There could be multiple charges. If there are, just pick one. Gold sulfide, we'll go +3 again. -2, 2, 3 yields. Gold chloride, AuCl, 3. And then chromium sulfide. +3, -2. So the 2 goes here and the 3 goes there. Because it's a solubility reaction, based on the format, I will need to check solubilities for each of these. The chlorides are generally soluble. So chlorides, and looking for gold here, it's not on there. So we will go with an AQ on this guy. And the sulfide would be insoluble, except for we don't have an exception. So we'll go with this solid on that guy. Alright, good reaction, having a solid formed. And balance it. Looks like it will be already balanced. I got 2 golds here, so I need 2 here, 6, and now it's balanced. A few things that you'll want to look at here, or to concentrate on, is one, charge balancing. This is probably the first place people lose points. Next would be these diatomic atoms like H2. We got H2. We have N2, O2, F2, Cl2, Br2, and I2. So these guys are very common. By themselves, they have to be diatomic. People lose points there. You will be required to draw a picture. In fact, you're going to draw 2 pictures. One involving a redox, exchange electrons, and the one involving solubility. You will have to do an ionic net and a net ionic. You should be able to do those, along with just a plain old molecular equation. Now, remember, we're going from an ionic. An ionic reaction removes what are called spectators, things that don't do anything. So for, let's say, this last reaction here, the chromium sulfide precipitate out, these guys stay dissolved. So remember, when ionic compounds dissolve, they separate. So my net ionic equation would be simply removing the spectators. It would be chromium +3 plus sulfide -2 yields chromium sulfide. I removed the guys that are just floating around in solution and don't precipitate or don't change. That is pretty much about it. Any questions? Should give me a holler.